All right, guys, here's the next way that they're going to create an example on this sort of stuff. There might have where you will be given either the velocity or acceleration functions. So up above, we always started with the position function, as you can see there. But if we come down here, they're going to start us with velocity. So a particle moves in a straight line with a velocity of t squared minus 3t plus 2 meters per second. So they want us to find the displacement of the particle after 4 seconds. Well, remember, displacement is its final position minus its starting position. And so I need to be using position function. Well, how do I get from velocity to position? Since velocity is the first derivative and position is the original, I need to take the antiderivative, or I need to integrate velocity in order to get to position. So there's my integral of velocity, but if I evaluate it between my starting value and my ending value, what I get is displacement. So that same definite integral, which meant area under the curve, it also means displacement. So if we actually do displacement from 0 to 4 for the first 4 seconds of our velocity function, dt, we'll get that as our answer. You can either use your calculator to work that out, or you could do it by hand, either one, but there's our displacement. Now, if I want to find the distance traveled, remember, displacement is just difference from starting point to ending point. Distance traveled, if the thing switches directions, is going to be longer than displacement. In order to get the distance traveled, what we're going to do is we're going to put the velocity function in absolute value symbols. We're still going to go from the start to the end, but we'll do it with the absolute value. What that absolute value does is it takes every time it goes backwards, it turns that into a positive distance rather than a negative distance. And so we're adding up all of our positive distances. So we just do the same integral, but we do it of the absolute value as opposed to just regular velocity. So from 0 to 4, absolute value of velocity, dt. Make sure just velocity is inside absolute value and that the absolute value is not around the whole integral. It needs to go integral, start absolute value, stop absolute value, then the dt when you use your calculator. You can do this by hand. We'll deal with that at a later date. Okay? So then the next thing that they might ask, what's the displacement function if the object is at -3 when t equals 2? So remember, all we know is velocity. What is the actual s of t function? Well, s of t, remember, is the antiderivative of velocity. So we'll do the antiderivative of velocity. Gives me 1/3 t cubed minus 3/2 t squared plus 2t plus c. But now we got to solve for c. Well, remember, how do we solve for c? We need to know some fact about the original function. Well, I gave you that fact. Object is at -3 when t equals 2. So that means if I plug 2 into s, the whole thing should equal -3, and I can use that to solve for c. And then I kind of plug that back in and write the final answer for position. So there's our displacement function. Okay? Displacement function and position function, they mean the same thing. Generally, when they're starting with displacement function with s, they'll call it the position function. When they're starting with velocity or acceleration, they'll refer to it as a displacement function. That's the way IB tends to operate. It's kind of weird that they don't use the same wording every time, but that's okay. So now, a couple other things that they're going to ask with this. They'll also ask about all the things that we did in the first example. When is it moving right? When is it moving left? When's it at rest? When is it speeding up? When is it slowing down, etc. So what's the acceleration of the particle at t is 3? Well, in order to get the acceleration, I got to take the derivative of velocity. So my velocity function was the t squared minus 3t plus 2. Its derivative is now 2t minus 3. Plug in 3, and my acceleration is 3 meters per second squared. Don't forget your units on these things. And then at t is 3, is the particle speeding up or slowing down? Well, why? Well, remember, that's the comparison between velocity and acceleration. So I need to plug 3 into velocity. I meant velocity was 1. I plug 3 into acceleration. Acceleration is 3. They're both positive. So that means the particle is speeding up because velocity and acceleration are the same sign. So it's all the same stuff. It's just the fact that you might be starting with acceleration or velocity, and you'll have to integrate in order to get up to position. So that should hopefully be enough for you to get going along the next one. Enjoy yourselves. Have fun.